This meaning is being brought to you by the fractal squared circle. For today, we'll be doing some identities, trigonometric identities, sum and difference identities, double angle and half angle identities. Sum and difference identities will ask about the trig functions of alpha plus or minus beta equals what? We'll start off with these two diagrams. We'll derive this one. We're on the unit circle. We move up a distance, clockwise a distance alpha. This point is cos alpha by sine alpha. We go counterclockwise. Clockwise an angle beta. This is at cos beta by sine of negative beta. Now we take the whole thing and we turn it by beta radians so that you get the same similar triangle. And so the angle here is alpha plus beta. So this is at 0.1 by 0, and this is at cos alpha plus beta by sine alpha plus beta. Now when you turn the triangle, this distance from here to here is the same as this distance from here to here. It doesn't change. So the same d, and so for convenience sake, we'll say the same d squared. D squared for this equals d squared for this. Now, okay, d squared is, by Pythagoras, it's the sum of the squares of the differences of the coordinates. So let's be on the left side, d squared is sum of squares of cos alpha minus cos negative beta plus sine alpha by minus sine of negative beta. Here, same distance squared, which equals the sum of the squares of cos alpha plus beta minus 1 plus sine of alpha plus beta minus 0. All right. We expand this, keeping in mind that cos of negative beta equals cos beta. Get cos squared alpha minus 2 cos alpha cos beta plus cos squared beta. Now here, a minus and negative cancels. This negative comes out, so it becomes a sine alpha plus sine beta. So you get sine squared alpha plus 2 sine alpha sine beta plus sine squared beta. On this side, the square of this will be cos squared alpha plus beta minus 2 cosine of alpha plus beta plus 1 plus sine squared alpha plus beta. Now I'm going to merge together the cos squared alpha and sine squared alpha here. Cos squared beta plus sine squared beta here. We have these other two middle terms, minus cos alpha cos beta plus 2 sine alpha sine beta. Then we'll add the cos squared alpha plus beta plus sine squared alpha plus beta here, plus 1 minus 2 cosine of alpha plus beta. All right, now cos squared alpha plus sine squared alpha is 1. Cos squared beta plus sine squared beta is 1. Cos squared alpha plus beta plus sine squared alpha plus beta is 1. So, okay, great. We get 1 plus 1 minus 2 cos alpha cos beta plus 2 sine alpha sine beta equals 1 plus 1 minus 2 cosine of alpha plus beta. All right. We cancel 1 plus 1 on both sides of the equation. And so we get minus 2 cos alpha times cos beta plus 2 sine alpha sine beta equals minus twice cosine of the sum plus beta. Now, if you divide throughout by negative 2, then you get cosine of the sum equals cos alpha cos beta minus sine alpha sine beta. This is the angle addition law. We could also do a cosine angle subtraction law by replacing beta by negative beta throughout. So this will become a cosine of alpha minus beta. Cosine of negative beta is just cos beta, so you get cos alpha cos beta from here. Sine of negative beta, the bit negative comes out and cancels this to a plus. So you get cosine of alpha minus beta equals cos alpha cos beta plus sine alpha sine beta. All right, now we'll put that down here. Cosine of a sum is cosine cosine minus sine sine. Cosine of a difference is cosine cosine plus sine sine. Now we can also use this rule to, if we substitute in here pi over 2 for alpha, and note that cosine of alpha over 2 is 0, and sine of alpha over 2 is 1, then right away this implies the complementarity rule that cosine of pi halves minus beta equals sine beta. And if we now substitute pi halves minus beta for beta here and here, and note that pi halves minus beta gets you beta. Then cosine beta equals sine of pi halves minus beta. Now we've seen this before. Complement trig of complement equals cotrig of angle. But this is for general angles, not just the acute angles. So we now have, oh, okay, we'll deal with that later. Now we're gonna use this complementarity rule to get a sine of some rule. Sine of alpha plus beta is cosine of pi halves minus alpha plus beta. And you can rewrite that as cosine of pi halves minus alpha minus a beta. So plugging that into here, you get that using this, and for the cosine difference rule, you get cosine of pi halves minus beta, cos beta plus cosine of alpha 1 times cosine of pi halves minus beta. So you get the sine of a sum, alpha plus beta equals sine alpha cosine beta plus cos alpha sine beta. If you substitute negative beta in for beta, this would be a sine of alpha minus beta. This would still be a cos beta. This would be a minus sine beta. Sine of alpha minus beta equals sine cosine minus cosine sine. So here we go. Sine of alpha plus beta is sine cosine plus cos alpha sine beta. Sine of alpha minus beta is sine alpha cos beta minus cos alpha sine beta. Then as you can see, there's some trig identities. Sine is tangent is sine over cosine, so tangent of a sum is sine of a sum over cosine of a sum. So sine cosine plus cosine sine, or cosine cosine minus sine sine. We divide numerator and denominator by cos alpha cos beta. Then these cosines cancel. Sine over cosine is tangent, sine over cosine is tangent. These cosines cancel. Sine alpha over cos alpha, sine beta over cos beta, like that. And sine over cosine is tangent, so tangent of a sum, from here we get the tangent of the sum is tangent alpha plus tangent beta, all that divided by 1 minus sine over cosine is tan alpha, sine over cosine is tan beta, and that's the trig angle addition formula. And if again we substitute negative beta for beta, so you get tangent of alpha minus beta, you get tan alpha, tan of negative beta would be minus tan beta. The tan of negative beta cancels this negative. So you get tan alpha minus tan beta over 1 plus tangent alpha tangent beta. So here are the angle addition and subtraction rules. Cosine of a sum is cos cos minus sine sine. Cosine of a difference is cosine cosine plus sine sine. Sine of a sum is sine cosine plus cosine sine. And sine of a difference is sine cosine minus cosine sine. Tangent of a sum is tangent plus tangent over 1 minus tangent tangent. Tangent of a difference is tangent minus tangent over 1 plus tangent tangent. So for example, let's find cosine and sine of 75 degrees and 15 degrees. 75 degrees is 45 plus 30. So you get cos 45, cos 30 minus sine 45, sine 30. Cosine 45 and sine 45 is root 2 over 2. Cosine 30 is root 3 over 2 here. Sine of 30 is 1/2 here. Root 2 over 2 times root 3 over 2 minus root 2 over 2, 1 over 2. Or root 6 minus root 2 divided by 4. Sine of 45 is sine of 75, excuse me, is sine of 45 plus 30. So sine, cosine plus cosine, sine. Sine 45 is root 2 over 2. Cos 45 is root 2 over 2. Cosine 30 is root 3 over 2. Sine 30 is 1 over 2. And so after a bit of work, it's root 6 plus root 2 over 4. Cosine 15 degrees. Well, all right, it's just going to be sine of 75 degrees, or root 6 plus root 2 over 2. Sine of 15 degrees is cosine of 75 degrees. So therefore root 6 minus root 2 over 2. So we now have the trigonometry of the 15, 75, 90 triangle. tangent of 75, tan of 45 plus 30, so tan 45 plus tan 30 over 1 minus tan 45 tan 30. Tan 45 is 1. Tan 30 is 1 over root 3. And over 1 minus 1 over 1 times 1 over root 3. And after a bit, it's root 3 plus 1 over root 3 minus 1. But we want to rationalize the denominator. We'll multiply above and below by root 3 plus 1. And the denominator, root 3 minus 1 times root 3 plus 1 is 3 minus 1, or 2. In the numerator, root 3 plus 1 times itself is root 3 is 3, plus 2 root 3 plus 1. Okay, after a bit of work, this becomes 4 plus 2 root 3 all over 2, and some cancellation later, you get 2 plus root 3. For tangent 15 degrees, I'll be cotangent of 75 degrees, so 1 over tan 75 degrees. So 1 over this, 1 over 2 plus root 3. To rationalize the denominator, we'll multiply above and below by 2 minus root 3. So in the numerator, 2 minus root 3, and the denominator, 2 squared is 4, minus root 3 squared is 3, 4 minus 3 is just 1, so we're just left with 2 minus root 3. So you have some examples. Here they ask, okay, here's a proof, and as I mentioned before, whenever there's a proof in the homework set, I do want you to go through all the steps, not merely say it's true. We know it's true. The point is to go through the steps. So here's sine of 3 pi over 2 plus theta is negative cosine theta. Well, start with the left, root 3 over 2, sine of root 3 over 2 plus theta. Sine of a sum is sine cosine plus cosine sine. Sine of root 3 over 2, that's 270 degrees, whose height is at -1. Cosine of root 3 over 2, winds up at 0, so this is 0. You get negative cos theta plus 0 is negative cos theta, and that's the right side. And we're done. Here we have, a complicated thing. Cosine of a difference of an arcsine and an arctangent. All right, cosine of a difference is cosine, cosine plus sine, sine. Okay, cosine of arcsine 5/13. Okay, we have a right triangle. Whose angles arcsine root 5 over 13, so opposite side 5, hypotenuse 13. And after a bit of Pythagoras, you get this adjacent side is 12. So this cosine of arcsine 5/13 is 12/13. Cosine of arctangent 3/4. Well, here's a triangle whose angle here is arctan 3/4, so 3 here and 4 here. And by Pythagoras, this turns out to be 5. So cosine of that is 4/5. So here we 12/13 times 4/5. Plus sine of arcsine cancels 5/13. Sine of arctangent, well, here we go. If here's an arctangent of 3/4, sine is opposite over adjacent, 3/5. So 12/13 times 4/5 plus 5/13 times 3/5. After a bit of arithmetic, it's 63/65.